Okay, so today I want to expand on kind of what we've been doing. And again, we're still going to talk about vertex. We're still going to calculate that. We're still going to calculate the axis of symmetry, but the new part is here finding that y-intercept. Again, why are we doing this? Basically, what we're trying to do is we're trying to find all those small parts and put them all together eventually at the end. That is my goal. So again, if let's say I know the vertex is here, I know my axis of symmetry is running right through it. Okay. As soon as I can find that y-intercept, let's say my y-intercept is somewhere sitting up here, somewhere above. Um, I can already see kind of this is going to be my right hand side of the parabola. Well, by using the axis of symmetry, I can quickly reflect it over and get the other side of the picture here. All right, ignore that line. I don't know why it continues to do that. It's bugging me. All right, but we can see kind of here the idea. So again, that's the basic idea. We're going to eventually find the x-intercepts so we can get a much, much better picture. So that's our goal. But again, we're breaking it up small chunks here at a time. So let's begin first of all. How the heck do I identify, how do I find that y-intercept? So again, what I want you guys to take a look at is all these crazy lines here. So again, if I notice, here's a y-intercept, here's another y-intercept, here's another y-intercept. Well, let me name those y-intercepts. So I start here at 0, I don't go left or right, so I stay at 0 and I go up to 5. So this one's going to be 0, comma 5. This one would be 0, comma 3. Similarly down here, I stay at 0, I don't go left or right, but I simply go down to -3. So it's 0, comma -3. Now notice all of my x values are 0. We're going to use that little idea and we're going to exploit that to help us find the y-intercept. So how do I find the y-intercepts? Well, that idea that I have to set x equal to 0 and I can solve for y. That's going to let me get my y-intercept. And again, I always want to write my y-intercept as 0, comma, whatever that y value is. Okay, this is a little refresher again. So what we did yesterday. How the heck do I calculate vertex? Again, key parts, standard form, find your A, B, and your C. What we want to do, this is the key idea right here. X equals -b over 2a. That's what I want to use to get the x value of my vertex. The way that I get the y value is I have to plug it back in eventually, and I want to write my answer as an ordered pair. Now the axis of symmetry, which is nice. Once you have your vertex, once you have your x, comma, y, it's just a matter of, let's take my x value. That is where my axis of symmetry is going to cross through. So we write it as x equals and then whatever that value may be. Okay. So let's jump here into example 1. So we'll start off with the vertex. We'll get into the axis of symmetry as review, and then we'll jump into the new part here, y-intercept. So let me have, let's calculate the following. So I have -x² minus 6x minus 3. Notice right here, my a, this one's kind of tricky, but it's a -1. My b is a -6. My c is a -3. All right, so the way we find our vertex, again, review, x equals -b over 2a. Well, I'm going to write negative. What's my b? Ooh, this is going to be tricky. It's a -6 over 2 times, well, what's my a value? Again, another trick here, -1. Well, the double negative up top gives me a +6. This keeps frustrating me. So up top again, I get +6 over -2. So 6 divided by -2 is going to give me -3. All right, so perfect. I know my vertex is going to be sitting at -3, comma, something. All right, so now how do I get the y value of my vertex? Again, we simply have to take -3 and we substitute it back in to get our y value. And again, this is going to be a common theme throughout. So what I'm going to do is I'm going to set it up real quick. Here we go. I just plugged it in. Again, that negative drops down. And I have, instead of x, I put -3. All right, now I want to simplify, right? And again, you got to be careful with that negative sitting outside. What I want to do first is take -3 to the second power, which gives me 9. But then I bring down that negative, which gives me -9. Now, -6 times -3 is +18 minus 3. Okay, 18 minus 9 gives me +9. +9 minus 3 gives me 6. So that means that my vertex is sitting at -3, comma 6. Now my axis of symmetry is going to be x equals, and again, the x value for my vertex, -3. All right, now getting into the new part here. I'll do this in blue. I'll break it apart here. To get the y-intercept again, I know my y-intercept has to sit at 0, comma, something from what we saw, right? Now again, here's the idea. Like I said, it's the common theme. If I know what the x value was up here, all I had to do was plug it back in. Well, if I'm trying to find my y-intercept, if I know that x is equal to 0, let's plug in 0 and see what happens. Y is equal to negative 0 squared minus 6 times 0 minus 3. Well, 0 squared is 0, and then 0 times the negative is just going to be 0. Negative 6 times 0 is 0. You can say minus 0 if you'd like. So we got 0, 0, minus 3, which eventually gives me negative 3. So I know this quadratic, this parabola, is going to eventually intersect at 0, comma, negative 3 on my y-axis. This is the y-intercept. So that one wasn't that bad. I think this is actually the easiest one to calculate because you're plugging in 0. A lot of the things really reduce down to be 0. All right, so here we go. Example 2. So again, I need to calculate the vertex, axis of symmetry, and the y-intercept. So let's do that one more time. My a value here is going to be that imaginary 1. My b is going to be negative 4, and my c is going to be negative 1. All right, so again, we're going to use that part of the formula. X equals negative b. Erase that. I don't know why it keeps doing that. Break my computer. Negative b over 2a. So again, I have negative b. Well, my b is negative 4. So again, be careful. Watch out for those double negatives. Over 2 times 1. Up top, we get double negative, which turns into a positive 4, over positive 4 over 2, which reduces down to be 2. So again, that is the x value of my vertex. It's also my axis of symmetry. X equals positive 2. Let's quickly find the respective y value. So again, all I have to do, again, that theme of constantly plugging it back in to get the y value. Here I have 2 to the second power minus 4 times 2 minus 1. Well, 2 squared is 4. Negative 4 times 2 is negative 8. Minus the 1. This gives us negative 4. Negative 4 minus 1 gives us negative 5. So my vertex is sitting at at 2, comma, negative 5. Now let me change the colors here so I can get the y-intercept really quickly. Now again, I know my y-intercept has to sit at 0, comma, something. So again, that idea of let's find that y value by plugging in 0 for x. So I get y equals 0 squared minus 4 times 0 minus 1. Well, 0 squared is simply 0. 4 times 0 is simply 0. And then minus 1. That means that my y-intercept is going to be sitting at 0, comma, negative 1. Maybe some of you guys for the y-intercept can already sort of start seeing that pattern of what value is really going to be my y-intercept. So on this one, I'll skip the vertex. I'll skip the axis of symmetry. Let's see if you guys can catch that pattern here. So find the y-intercept. Let me put 0, comma something, right? And so again, let me plug in 0 for x. So I get negative 0 squared plus 6 times 0 minus 8. And again, here we see a few things happen, or a few things reduce to be 0. So again, 0 squared is 0, and the negative doesn't really matter. It's still going to be 0. 6 times 0 is 0. 0 plus 0 minus 8 is simply going to be negative 8. So hopefully with that one, maybe some of you guys catch it. If you don't catch it, continue to do this. Again, this will always work. Okay, let's move on to these last two special cases. Here I have x squared minus 16. Again, this one I will actually do the vertex. So again, here we have x equals negative b over 2a. And this is again be one of those special cases because I'm missing something, right? I have my a value, which is 1, my b value, which is missing. So that b value is going to be b value y. I'm going to strangle this computer. So I kind of got cut off, but again, here I have b. Again, it's missing the middle part, so that's going to be 0. C is going to be negative 16. So what I've done is I already plugged it in, right? Negative b over 2a. My b was 0. 2 times 1, which is my a value. Well, up top in my numerator, whoa, all right, up top in my numerator, I'm going to get 0 over, I swear I'm going to strangle this computer, I'm going to break it. Okay. I am going to get 0. 0 divided by 2 is simply 0. So again, that lets me know that my vertex is sitting at 0, comma, something. So again, the way we get that, let me find my axis of symmetry. That's just going to be x equals 0. All right, let's plug that back in. Y equals 0 squared, parentheses there, minus 16. Well, 0 squared is simply 0. 0 minus 16 is going to give us negative 16. My vertex is sitting at 0, comma, negative 16. Well, let me find my y-intercept. All right, let me change colors here to blue. And again, it's going to be 0, comma, something. Again, those of you guys that caught it can already tell that this is going to be simply negative 16. Again, let me jump into it so I can show you how I got that. Y equals, I'm going to plug in 0 for x, so I get 0 squared minus 16. So I get 0 squared, which is 0. 0 minus 16 is going to be negative 16, which is kind of interesting, right? My vertex and my y-intercept are the same. All right. So let's move on to the next one. All right. Now again, what is special about this one? Well, this one's missing that last piece, that's C. But let's go through it. My A value. Let me change colors real quick. My A value is 1. My B value is negative 2. And my C value, it's missing. We can say plus 0 if we want or not. I guess it doesn't want to. That is my C value. So what I'm going to do is I'm going to plug it in real quick into x equals negative b over 2a. And I'll get back to you in a second. Again, I have a, b, and c. I plugged in negative 2 for b. So again, careful with that double negative. The formula does have a negative at the beginning. 2 times a, which is 1. Up top, I get double negatives, which give me a positive 2 divided by positive 2, which is 1. My vertex is at 1, comma, something. Right? And again, I always like to kind of cheat. I can already say my axis of symmetry is simply going to be 1. All right, let me plug it back in. Y equals, I'm going to plug in 1 squared minus 2 times 1. And again, I don't have a c, so that's kind of cool. Less work for me. I have 1 squared, which is 1. Negative 2 times 1, which is negative 2. Well, 1 minus 2 is going to give us negative 1. My vertex is at 1, comma, 1. All right. Now, last one here. Let me find my y-intercept. And again, let me change colors so we can tell them apart. So here we have my y-intercept. It has to be 0, comma, something, all right? So again, that same theme, that constant theme of if I have an x value, how do I get the y value? I simply plug it back into the function. Y equals, and we're going to plug in 0 squared minus 2 times 0. Well, this is weird. What is 0 squared? 0. 0 times negative 2 is, well, minus 0. 0 minus 0 is simply going to be, I hate this computer. Hope you guys are having a nice day today. Equals 0. So my y-intercept is going to be at 0, comma, 0. All right, guys, that was the last one. Your assignment is right here. So you guys have 6 problems. They go by very, very fast. All you guys have to do is calculate that vertex, that axis of symmetry, and then the y-intercept again. Make sure that you guys write your vertex as x, comma, y. Axis of symmetry is x equals whatever value, and your y-intercept as 0, comma, that y-intercept. Right. Have a good day, guys. I will see you guys tomorrow.